Okay, so welcome to Math 1100. Okay, so we're going to look at complex numbers. We already did a bit of an introduction on complex numbers. We said a complex number is a number in the form z is equal to x plus I y, where x is the real part and y is the imaginary part. Okay, so aside from that, today we're going to go a bit further. We're going to look at the operations on complex numbers. Okay, so when we say operations on complex numbers, we mainly mean how do complex numbers behave when we come to addition, multiplication, division, and subtraction. So addition and subtraction, we're going to put them together. Then we're going to look at multiplication, then division. Okay, so we're going to start with addition. 1. Addition and subtraction of complex numbers. Okay, so this, just like we add numbers, this is similar to grouping group the like terms. You group the like terms. That is, you group the real numbers, the real part, and the complex part. Okay, so if we have a complex number z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. Okay. If we choose to add these numbers, we say z1 plus z2. This simply means, so we're going to get the z part here. So we have x1 plus y1 plus the z2 part, which is represented by x2 plus y2, x2 plus y2. So, whenever we're adding two complex numbers, we have to collect the like terms. So here, if you can identify here the like terms, we have x1 here and x2 here. These are the real parts of a complex number. So we're going to group them together. We're also going to group the imaginary parts of the complex number, which have iy1 and iy2. So let's group them together. So here, this is going to give us x1 plus x2 plus iy1 plus iy2. Okay? So we have x1 plus x2 plus, here we're going to factor out the I, and it's going to be y1 plus y2. So simply, if they tell you to add two complex numbers, we have complex number z1 and complex number z2. You simply are going to collect the like terms, which is the real parts, you add them together, and the imaginary parts you are going to add them together. So remember, as we said again, this part is called the imaginary part, and then this is called the real part. I think I never said that. Okay, so now, what if we subtract these two numbers? Z1 minus Z2. What are we going to have? Okay, so again, what is our Z1? Our Z1 is X1 plus I1. What is our Z2? So here we're going to introduce the brackets here. Our Z2 is going to be X2 plus IY2. Okay, so we're going to do the same thing. We're going to connect it like this. But here, if you have noticed the brackets here, so we have to get rid, we have to expand those brackets. We have to expand now. We have X1 plus IY1. So I'm going to multiply the negative sign throughout. We have X2 minus y2. Okay, so we collect the like things again. So the x1 and the x2 will come together. We're going to group them together. We're going to have x1 minus x2. Okay, and then we're going to group the imaginary parts as well together. So this is going to have plus I, again we factorize, y1 minus y2. As simple as that. So now, this is how we go about when we're adding and subtracting complex numbers. Let us try and look at an example. Okay. Example. Express in the form of a complex number x plus iy. Okay, so we have a 2 plus 3i plus negative 4 plus I. B 2 minus I5 minus negative 4 minus I. And the last one, C, which is 2, make the second from last, 2 plus I9, A 3, I3 minus I plus 6I. Okay. So, generally, in this question here, they have just told us to express these expressions in A, B, C, and D in the form xc plus iy. So it's up to you to identify whether we're going to add or subtract these complex numbers. Okay, so you can pause the video, try and answer out these questions. Try and answer out these questions. That's when I can continue this question. So just pause the video right now. Okay, so let's continue now with the solution. Okay. So for A, okay. So we have 2 plus I3 plus negative 4 plus I5. So again, all we have to do, we're going now to get rid of the brackets here. So this is the same as 2 plus I3. So this is going to be negative 4 plus I5. Okay, from there, we're now going to group the like terms. So we're going to group the real parts and the imaginary parts. So here we have 2 minus 4 plus I3 plus I5. Okay? Here, 2 plus 4, what is it going to give us? It's going to give us negative 2, and then I3 plus I5 is going to give us C plus C, I8. As simple as that. Hope you all got the same answer. Okay, now let us try out B. B. 2 minus I5 minus negative 4 minus I5. Okay. So here we have this question here, a complex number. Hope you tried it out. So we have a complex number here now. So there is this complex number here and this complex number here. And what we're doing here, we're subtracting them. So let's see what it's going to give us. So before that, we're going to expand this now. We're going to remove the brackets from this one. It's going to be 2 minus I5. We multiply negative times negative 4. It's going to give us plus 4. Negative times negative I5 is going to give us positive I5. From there, henceforth, we are going to group the like things. Okay, so the real part is going to be 2 plus 4, and then the imaginary part is going to be negative I5 plus I5. So 2 plus 4 here is going to give us 6. This is going to give us 0. Therefore, the answer there is 6. If you manage to get 6, then you got it correct. Okay, so we can see here that the value, sometimes the value doesn't give you a complex number, but just know it can give you a single value like 6 here. Okay, let us try out now C and see what it's going to give us. So I'm just going to run here as well, so that we have a lot of space. Okay, let us try and look at C here. So for C we have 2 negative 2 plus I9. Okay, so this is also a complex number here, but the imaginary part has a, has a value of 0. So when you multiply 0 times the I part, that's going to give you 0. So let us try and add this. So it's simple. It's just going to be 2 plus. So here it's going to give us negative 2 plus I9. So here all we have to do is correct the like things. Okay, so what is 2 minus 2? It's going to give us 0 plus I9, which is going to give us finally I9. Okay? From there now, I hope you all got that answer correct, I9. Let us now try D. Okay? So D, we have I3. We have I3. Let me just get this so I can right. This is I3 minus 5 plus 6I plus I6. Okay. So here we have a situation where we have the one complex number is only having an imaginary part, and the other complex number is having both the real part and the imaginary part, and we're subtracting them. So we follow the same procedure of collecting like this. So this is going to be I3. So here we're going to multiply the negative throughout this expression here to get rid of the brackets. So it's going to be negative times that, which is going to give us plus 5, negative times that is going to give us negative I6. So again here we're going to collect the like terms. So from the like terms here we have 5 plus I3 minus I6, which is going to give us 5. I3 minus I6 is going to give us negative I3. So that's a simple way we can go about adding complex numbers. So we have been given different scenarios here. We have been given a scenario where we are adding 4 complex numbers, where each complex number has a real part and imaginary part, and also subtraction, that is A and B. And then on C, we have been given an example where we have only been given the real part. Okay, we add the real part of one complex number and another complex number. And then here we have an imaginary part added with a complex number. Okay, so that is it on addition and subtraction of complex number. So now we're going to go to multiplication. Okay. Okay, so I'm just going to erase this so that I can have a clear board. If not me through. Okay, so if Z1, which is a complex number, is equal to X1 plus I Y1 and Z2 is equal to X2 plus I Y2. Then, if we want to multiply complex numbers, we're going to write in this form. Z1 dot Z2, which is equal to, so here we're going to substitute. While is Z1, we're going to put that there, which is X1 plus I Y1 and Z2, which is X2 plus I Y2. Okay. So just like the way you wish to multiply in algebra, it's the same way we're going to expand this in here. Okay, so we're going to multiply x1 throughout that expression there and iy1 throughout that expression there. So we're going to multiply. This is going to be x1 times x2, giving us x1, x2. Okay, x1 times iy2 is going to give us plus I. So remember the imaginary part, the I will start first. X1, Y2. Again, we're done with the X part. Now let's try and multiply the IY1 part. So IY1 times that times the X2. This will give us, I X2, Y1. Okay, is it clear? Yeah. Ix2, Y1. And then now we're going to multiply this IY1 with the IY2. But remember, there's a catch here. Okay, I hope you can recall the catch. Okay, when we multiply I times I, whenever we multiply I times I, it always gives us -1, which means I squared is equal to -1 when we're dealing with complex numbers. Okay, so we're just going to include that term here when we multiply. So I times I, which is going to give us a negative value, y1, y2. Okay, so if you are able to see in this expression here, we have the real parts which don't have i's and the imaginary parts which have i's. So let's group them together. Okay, so this is going to be x1, x2 minus y1, y2. Put them in brackets. We put them in brackets, and then we collect the like terms here, which is plus I. So we're going to have x1, y2 plus x2, y1. As simple as that. Okay. So that's how we go about multiplying complex numbers. Okay, so let us try and look at an example, some few examples on multiplication of complex numbers. So we have examples. Simplify each of the following. expressions in the form x plus iy, in the form x plus iy. So we have our n, which is 6 minus I3. We have our b, which is 2 minus I3 plus I. And finally, our c, which is 5 plus I3 squared. Okay. Okay, so let us try. You can pause the video and try out and solve these examples following the concept which we have here. You can try it. You can pause the video and try and answer that. Okay. So let us now try this one. Solution. Okay, so we have the first one here, A. Okay. So we have 6 minus I3. So for this one, it is very straightforward. It's a very simple question, this one. All you have to do is multiply. So I'm going to multiply 6 times I times I3, which will give us 18, I18. Okay? And then we come to this part here, negative. So remember, I times I is always negative 1. So here, there's already a negative number here. Okay? So we can say I or I squared is equal to negative 1. So let's write it in that form. So this will give us minus I squared 3. Okay, but remember this I squared here is negative 1. Okay, so we're going to multiply that. So it's going to be I 18 plus 3. As simple as that. But remember, we have to put it in the right form. So it's going to be 3 plus I 18. That's when we have multiplied our complex number there. Okay, so let me just run the other side so that we continue. We continue multiplying this with wonderful matrices, or wonderful complex numbers. Okay, let's go to B. So our B is 2 minus I 3 plus I. Okay, so let us try and multiply that. So we're going to go with the same procedure. 2, what is 2 times 3? It's going to give us 6. 2 times I, it's going to give us plus I2. Again, we multiply here, negative I times 3, it's going to give us negative I3. And then here, negative, so it's going to give us plus. Remember, I times I is going to give us a negative. So negative times negative is going to give us positive 1 there. Okay? So let us now try and group the like terms. We have 6 plus 1 plus I2 minus I3. This is going to give us 7. 7. What is I2 minus I3? It's going to give us negative I. Okay? So that is it. We have multiplied those two complex numbers there. So let us now try out the last one. I hope we're all in the same line here. Let's try the last one now. So the last one, C, we have 5 plus 3 plus I3 squared. So if you have an expression like this here, this is the same as 5 plus I3 multiplied by 5 plus I3. So let us try and multiply that expression there. Okay. So we do the same thing here. 5 times 5, it will give us 25. We're going to multiply 5 times I3, it's going to give us plus I15. We're going to multiply now, we come to this I part now, I3, again it's going to give us plus I15. And then here we have I3 times I3. So remember, the I times I is going to give us a negative. So 3 times 3 is giving us 9. So now we have to group the like terms now. So we have 25 minus 9 plus I15 plus I15. Okay? Plus I15. Okay. So now here, what is 25 minus 9? What is 25 minus 9 going to give us? Going to give us 16. 16 plus I30. That's it. That's how we multiply complex numbers. So they can give you in any form. There are different scenarios in which you can answer this question. Okay? So this is a simple way you can go about it. If you have any question, you can comment on the comment section there, and we'll see how we can go about it to help. Okay. So now that we're done with multiplication, let us now try and go to division. Okay. Okay, I hope you have all gotten this. Let me just grab it so the board is clean. Right. Okay, so I've come now to division of complex numbers. Okay, last part. Division of complex numbers. Okay, so for this one, we'll just go. Okay, so what do we do when we're dealing with division of complex numbers? Okay, so we multiply the numerator and the denominator by a conjugate of a denominator. So we'll explain these things as we look at this example. Okay, example. Express following in the form x plus I. So we have a here. 3 minus I over 4. So if you have an idea, you can just try out. If you have an idea, you can try it out. You can try and answer that one. You can pause the video, try out your mathematical way you can answer that question before we go to the solution. So you can just pause the video and try it. Okay? Okay, let us look at the solution. So we have this complex number 3i over 4 minus 2i. So if you can see here, there's an over sign here, this one. So this means division, okay? It means division. So here, if you see there are two complex numbers here, there's the one which is the numerator and the one down which is the denominator, okay? Denominator, okay? So the denominator, we're going to write the what is? We're going to write the conjugate of this one. I'm going to multiply the conjugate of the denominator on all the complex numbers here. So the conjugate is simply the opposite of this one here. Okay? So the conjugate of this one is going to be 4 plus 2i. So this 4 plus 2i, we just change the sign here. We're just going to change the sign here to make it the conjugate. Okay? This 4 plus 2i, we're going to multiply it with everything there. Okay? So remember why mathematics we just build on the things we have learned. So we have already looked at how to multiply complex numbers. So I'm going to multiply this top matrix with this one there, and this one there. So yeah, let's do that. So here I'm going to do the derivative thing. So 3 times 4 is going to give us 12, and then 3 times 2i is going to give us plus. Oh, sorry. So this is I. You just write it properly. I2. Write it I2 like that, so that you don't get confused. Same here. I2. Okay. So now let's multiply now. So that times that is giving us 12. 3 times I2 is going to give us I6. Okay. We come to the negative I here. Negative I times 4 is giving us negative I4, and negative, so here it's going to be a plus 2. Remember, I times I is always going to give us negative 1. Okay, so now we come to this one here, the bottom part. So everything this over 4 times 4 is giving us 16. 4 times I2 is going to give us plus I8. And then we're going to multiply here again. We come to the imaginary part here. So it's going to give us negative I2 times 4. It's going to give us negative I8, if you have seen here. And then here we're going to multiply negative I2 multiplied by I2. So remember, I times I is going to give us, so we're going to have a positive sign here. 2 times 2, it will give us 4. So what is remaining now here is we're going to simplify now this expression. We collect the real part and the imaginary part, we put them together. Okay, so here we're going to be 12 plus 2 plus I6 minus I4 over. So here we're going to have 16 plus this 4 plus I8 minus I8. Okay. So here, what is this giving us here? It's going to give us 14 plus what is I6 minus I4, which is going to give us I2 over. So here we have 16 plus 4, which is going to give us 20, and then here I8 minus I8 is going to give us 0. So I just going to write the 20 there and put it here. Okay. So another way of writing this is the same as 14 over 20 plus I2 over 20. Remember when we're dealing with fractions in somewhere grade 1, grade 2, where you have to find the common denominator. So this is just the same as that. Okay, so here now we have to simplify this expression in its lowest stage. So we find a number in which can go into 14 and 20. So we have 2. 2 into 14 is 7. 2 into 20 is 10. Plus 2 into 2, we're just going to bring the I there. Okay, so since it's a fraction, you can just write it 1 over. This will give us 10. As simple as that. Finish one done. So that's how we divide complex numbers. So for division, I know it can be a bit complicated, but with a lot of practice, you can answer it very easily. So remember what we did again? Here, we had to come up with the conjugate. Okay, so the conjugate is just a complex number which is opposite here in sign here. Okay, so here if we have 4 minus 2i, the conjugate of this is 4 plus 2i. If we have a complex number, we have a complex number 2 plus 3i plus i3, the conjugate of this one is just going to be 2 minus i3. It's as simple as that. If we have 3 minus i2, the conjugate will be 3 plus i2. So if you notice here, only the sign is changing there for conjugate. So for the conjugate, we are going to multiply it with both the numerator and the denominator. And then that's how you can come up with a complex number. Remember, we learned how to multiply complex numbers. So this part here, you just go, you can just rewind the video on the part where we're multiplying complex numbers, and it will help you through that. Hope there are no questions. So if you notice on these questions that I've given you, it's up to you to determine whether you're going to add or subtract, multiply or divide complex numbers. So I'm going to give you some practice questions which I'm going to try out. Okay, so you just take your time, go through the video. If you don't understand, go through the video again so that you can get this. Let me just give you some practice questions. So task. Okay. Express the following in the form x. So we have a 3 minus I plus 2 plus 3i. We have b. So here it's I3. Then b 4 minus I 7 plus I. C, we have 3 plus I2, 3 minus I2. D, we have 4 minus 5 minus I5 squared. And last but not least, we have E. Let me just write the E here. We have 2 plus I3 over 4 minus I2. Okay, so you try out those simple questions. So remember, we're expressing, pay attention to the instructions here. We're expressing all of this in the form x plus iy. Even after we divide, like in the previous example, we couldn't leave it at this point because we had to leave it in the form x, we have the real part, plus iy. So we have to always put it in that form, depending on the question. All right, thank you. That ends today's lecture on complex numbers. So I'd advise you to practice more questions, try out these questions. If you have any other questions, you can just comment or contact me. Thank you very much.